Stereochemistry is the study of the three-dimensional arrangement of atoms in molecules. Molecules that have the same connectivity of atoms but have a different spatial arrangement of atoms are known as stereoisomers. Take ibuprofen, for example. We've drawn it using a perspective drawing such that the hydrogen atom is coming out of the screen and the methyl group is pointing behind the screen. Ibuprofen can be drawn such that these two groups are reversed, where the methyl group is coming out of the screen and the hydrogen is behind the screen. Both of these structures are known as ibuprofen because ibuprofen is a molecule in which isobutylbenzene, hydrogen, a carboxyl group, and methyl are attached to the same carbon. The atoms in these two structures have the same connectivity because they are bonded to the same corresponding atoms. Although the connectivities are the same in these two structures, they are unique and different molecules. Notice that carbon number 2 and only two of its attached groups of atoms can be superimposed at any given time. Chemists use the term chirality to describe molecules that exhibit a special kind of stereochemistry. The ball and stick model shown here represents a carbon atom connected to 4 differently colored spheres. These colored balls are representative of any kind of group as long as no one group is the same as another. If it were possible to place our representative molecule in front of a mirror, it might look like this. Notice that there's a molecule in that mirror. Let's remove the mirror from the picture while leaving the molecule behind. Now we have two molecules, the original structure on the left and its mirror image on the right. The question we will ask over and over again as we study stereochemistry is, are the original molecule and its mirror image the same compound? How can we determine this? As we saw in our previous example of stereoisomers, we need to manipulate one of them and see if we can match up all its atoms with the other. As you can see, two of the groups don't match up. These two molecules are said to be non-superimposable. A molecule that is non-superimposable on its mirror image is called a chiral compound. We can also say that the compound possesses chirality. Not all compounds possess chirality. The molecule shown is superimposable on its mirror image. Compounds that are superimposable on their mirror images are known as achiral compounds and do not exhibit chirality. This mirror image test is a way to determine whether or not any object or molecule is chiral or achiral. We can do this, for example, with the drug ibuprofen. All we need to do is draw its mirror image. Now manipulate the image by rotating it 180 degrees, like so. We can see that many atoms of both molecules coincide. However, the methyl and hydrogen do not. This was the same situation we had earlier when we were introducing the term stereoisomers. Since these two isomers of ibuprofen have the same connectivity of atoms, but a different 3D arrangement, they are stereoisomers. The original molecule is chiral because it is not superimposable on its mirror image. Finally, if these structures represent two distinct molecules, we need a way to name them so that we'll know whether we're referring to the ibuprofen on the right or left. Chemists use the symbols plus or minus to distinguish between chiral mirror image structures. We will learn what these symbols mean in another tutorial. Incidentally, plus ibuprofen has therapeutic pain-relieving properties, while minus ibuprofen does not. The varying medicinal effect of chiral molecules is just one reason why the study of stereochemistry is so important.